Hello, this is John Haverlack with the University of Alaska Fairbanks and RV Sikuliaq, and I'm going to do about a 20-minute video introducing the Sikuliaq IT Asset Manager data acquisition tool. And you can get to the code and download the software for this system at www.sikuliaq.alaska.edu /get/skq/skq-it-am. So this is a relatively quick piece of software I wrote. We're at version 1.01 as of yesterday, and it's a cross-platform. It's built on a cross-platform open source network with a minimally invasive install using native system calls to collect data about each operating system and the software installed. Runs without administrative privileges for the most part, and it facilitates centralized data collection of an organization's computers so you can generate reports and get an idea as to how up-to-date your systems are. So I'm going to walk through the installation today and then run a few clients and take a look at some of the data that we are able to analyze as a result. Okay, so first thing to do is to get a system that you can install on, and that I know it supports Debian 10, Raspbian 10, and CentOS 7 on the server side. On the client side, it supports Windows, Mac, and Linux systems. So on the server side, it should actually run on a Windows system for the server side. I just haven't written the install script for Windows yet, so I haven't tested that yet. But the code itself is written in Node.js and is cross-platform and should work. Okay, so to do this, what I've done is I've set up a Raspberry Pi. I've got a Pi 2 Model B running. And you can see up here it's got about a gig of RAM and 4 CPUs, and you just did a fresh install on it, and so I've got a relatively clean stock system here. So I'm going to run this git clone command over here. Let me go copy it again. So this would be a server install, so we'll go out, get that code base, and install it. I think this is about a 20-minute presentation or so. We'll try to keep it to that. Okay, so once we get that installed, the next step is going to cd into the directory and run the server setup script. So we're going to get in there and run the server setup script. So what this is going to do is it's going to go out and download the dependencies for the software, which in this case is Node.js version 8 for several different platforms. So for OS X, Darwin, Linux, Mac, Windows, and so on, Raspberry Pis and such, it's going to go get the Node.js software for version 8, and then it's going to finish setting up all the dependencies for the server-side software. So once it's installed, the system actually no longer needs an internet connection, and as long as the clients have IP access to the server, the clients themselves don't need an internet connection, because everything they need to run is they get from the server. So they'll be able to download and install that from the server side. We'll see how that works. Okay, and then once this is going to take a few minutes. Once this is done, we'll start the server with the startup script, and we'll see something similar to this. And then we'll get to the web interface for it as well. And you'll notice it's getting version 14.17.1 for the server. So the server runs on a more recent version of Node.js than the clients. And the reason for that is I wanted to run on older operating systems, and I wanted to make sure I had a backwards compatible version. So I used an older version of Node.js for those older clients. And so far it's not too intensive on the CPU. We still got 60-some% of CPU idle as we do. Okay, so that got done. So I'm going to start the server. And so it's been started. We're running version 1.01. And it says that you can get to the web interface at this link. So we're going to copy that, come over here, and connect to it. All right. And a little bug I got to fix. This first time you load this web interface, it doesn't load correctly, so you just have to reload it. And then it loads these commands. So I have that on my list of things to fix. So in the web interface, you've got a few menu items up here at the top. An About menu. It runs under an ISC open source license. Here's my contact info if you have questions or find bugs. There's a change log, summarizes some of the changes that have happened, bug fixes, features to be added down the road, and the stats and the assets and the data don't work right now because we haven't collected any data yet. So if you go there, you're just going to get empty information. Okay, so back to the main homepage here. On the client side, I will also mention this. You run it as a non-administrative account on the client side as well as the server side. So you might want to create a separate user account for it if you're running it in production. I just ran it as the Pi user in this case. But this runs on port 8411 on the local host, on the Pi in this case. And that is not secure, so it's not running with any SSL or anything safe. There's no login for it, so there's no administrative access to prevent people from logging in and seeing it on your network. So for that reason, I recommend only running this. I think I put it under caveats. You should only run this on internal networks, not open to the internet. If you run it on an internet IP, firewall off, what systems, your internal networks are the only ones that should be able to access it. The data that it collects is not particularly sensitive, but could be used maliciously by someone if they want to know what version of what software you're running and find vulnerabilities. They could do that. Okay, so that said, let's go take a look at what the client side is going to look like. So for the first client, I'm going to run on the Pi that we have as our server. I'm just going to get this Linux command, and I can do that by clicking the copy button and then come over here and paste it and hit enter, and it goes out and downloads the client and runs it. And so what it's doing, and it's got a little message here about this sudo command. I'll show you how to run that again on another system. But it's got 496 packages to process, so it's going to take it a little while to run through and collect data on those. This DMII decode doesn't really matter on the Pi, so I'm going to ignore that for now. But we're collecting our first data on the first client, which is the server itself. So let's go get a couple more clients. Here I have a Debian 10 system, so I'll copy that again and paste it. And in this case, I will pay attention to that command if we get that message again. Now, this is the only example where you need permissions. So there's a command called DMI decode that must be run as root. And so what I've done is I've got a script here that if you run this once as root, it goes ahead and collects the data about the hardware or the motherboard for the system and sends it to that file. And you'll notice it stores all data under this .skqitam directory in my home directory. So it doesn't install anything globally on the system. Everything's stored under that directory. So now I can go rerun that wget command and let it collect data on this client. And it spits out some metadata about the client too. So it knows it's Debian 10. It knows it's got 8 CPUs and 32 gigs of RAM, and some various other metadata about it. It generates a unique host ID for each client. So that's unique to each OS install on each client. All right, so while that one's running for Debian, let's go get, I've got an OS X system here in the green window. And so let's go get the curl command for Mac. I'll copy that to my clipboard and paste. And so we will run the curl command on the Mac as my non-administrative user, non-root. And down below here we can see the Pi finished and succeeded, so it uploaded successfully to the server side. So the server now has some data. And by the way, on the server side, this Git repository that you checked out has all the code and everything under that one directory. So if you ever wanted to delete the server side, you would delete that. All of the data is stored under this itam data directory on the server side. So if you want to poke around and see data, you can find it under there. Okay, let's get back. Let me find my terminal windows here. There's one. There's the other. So we'll keep an idea on the status of how these are running. So this is running Mac OS 10.3.1, and it's going out and collecting data about that Mac that it's going to send back. So the last system that I'm going to go see if I can get information about, which I may or may not, is a Windows system. Let's see if I can connect it. And I may need to go browse. Is that going to work? I may or may not be able to do this here today. Okay, so it doesn't like that. Let's see if I can fix that real quick. Well, that looks right. Apparently it's not got the right network. Let me go get it networked while we're finishing this up. It'll probably take me a couple minutes while this is running. I'll be right back. Okay, let's try this again. Different IP address on the client this time. That was 149. Looks like it's doing something. Okay, good. We've got a Windows system here. Let us fit it to screen. Fit to window. Okay. Alright, so this is a Windows 10 system, and we're going to quickly go see what was my IP address. Well, maybe not so quickly. Okay, so 129. Let's go there. 10.1.0.129. See if that loads. Oh, I can't get there from here. That's right, it's on the wrong network. Well, maybe we can fix that. Should have really prepped this beforehand, but it should only take us a second. And it looks like you're still waiting for our other Debian client anyway, so that's fine. Let's see if this works. Okay, so the Mac finished. We got data from the Mac. And the Debian system is still running. And while we're at it, we can do a Windows 10 system here. So, get myself a little coordinated here. Okay, so on the Windows system, we are connected to our server, I do believe. Yep, 10.10129. And so if we scroll down to Windows 10, I can copy this command and come to my terminal and run PowerShell over here. And it should go out and do a very similar thing to what we're doing on the Linux side of the house. It installs it under the app data local SKQTAM system and directory. So it's under your app data local directory is where it installs the client. And so it should go out and run the client on the Windows system and collect data on it. And it'll take a few minutes to do that. It knows it's Windows 10, knows what version, and it went out and ran. So we've collected data on the Windows system as well, which is all I wanted to demonstrate there. Windows 7 is similar. I don't have a simple command line to copy and paste for it yet. So in the meantime, what I do is you download this installer. Let's reload this. There should be a link there. There we go. You download this zip file. And then that zip file will you download locally to your downloads directory. You can extract it under the downloads directory in this directory. That directory is important. It's hard-coded. And then run this batch script under there. And then it will go out and collect data on Windows 7 systems using PowerShell 2 instead of PowerShell 5. Okay, so that's really all there is. And then from that point on, you can simply rerun the batch file, and it'll update it if you need to rerun it. You can, by the way, rerun the client script as many times on the clients as you want, and it'll just get the latest data and update it on the server side. Okay, so that said, we finished here our Debian system. Okay, so now what I want to do is on the server side, under the ITAM directory, there's an analyze data script. So, and I mentioned if we go to the assets, we're not going to see anything here because we haven't processed any of the data we've collected yet. So this isn't automated yet. You have to go run this little script by hand. You can run it and rerun it. It doesn't take very long to run. And eventually I'll automate it. But now if I go to assets, I'll see that I've got 2 Linux, 1 Windows, and 1 OS X system. So we get a little pie chart breakdown of our distribution. And then I can see metadata about each of those systems. So we'll come back to that in a second. Under stats, you can see the breakdown of the different versions of the OS. So we've got a Debian 10, a Raspbian 10, Microsoft Windows 10, and Mac OS X. And then we've got systems installed by year. So we've got 2 installed in 2020 and 2 installed in 2021. Down here, we have an attempt to do what's called a relative version match. So of all the systems, all the applications, and all the systems it knows about, it compares each system to that master database of the systems we have and gives a relative scoring from 0 to 1 on how up-to-date each application is. So, of the applications we have, it knows about 2,617 software applications, which are packages or apps. It's saying most of those are up to date because we don't have a whole lot of data here to compare to. They're largely up to date. We can then look at that on a per host basis and say, okay, well, how up to date is each host instead of each application, and we have similar scoring. Okay, so as you install more systems, if you make sure that of each of the different OSs you have, that you have at least one system that's patched and updated, then you have the best, that's your comparison for all the other systems to be compared to. So that's the goal. So it's not authoritative, it's not going out to the vendors, finding the latest version of the software. That's a hard problem. But the easy problem is just to keep a current one, and it gives you some notion of how up-to-date your systems are. Okay, so let's go to assets. We got a nice little table here. And we can see each of our assets. You can query them. So for example, if I search for Pi or Raspberry, I can find my Raspberry Pi, and then I can reset that. So it's a really simple search filter right now to find systems quickly. So over here on the left, it shows you the asset ID and the serial number, if it is able to detect the serial number for that hardware. And in this case, I have a ID tag but no serial number because it couldn't find one. And then it tells us about the host name and the operating system and the version in which date it was installed. It tells us that this is an Apple Mac Mini 7.1 hardware-wise. This is a obscure piece of hardware. I don't know what make and model that is. I think it's a Partaker system, Partaker maybe. I've got an LG laptop with this version, a Raspberry Pi, and it shows the model of the Raspberry Pi. And then it lists the CPU, RAM, and network information for your network cards on various systems that you have. That does not detect disk storage yet. That would be something we could add down the road. And then inventory tells us about when they were last inventoried. And so as this data ages, we'll see this go up. And if things are over a year, then they're marked red. And then it tells us some notion of the relative up-to-date score. So this says of the 347 applications installed, 343 are up to date. And of these ones, and it's what it's doing here is it's actually comparing of all the applications I know about. I know that, hey, there may be one on this Windows system that's more up to date than I am. So we're getting these relative scores. And it's comparing all packages, so that's why you don't see any at 100%. Okay, so there's a quick summary of that. If you go to data, you can download data. This software inventory isn't working yet in the middle. I need to fix that. But I could, for example, go get device inventory, save that, open it up in a spreadsheet, and import the CSV. It saves it as CSV, and so I'll get the raw data into a spreadsheet that I can then do whatever I want with it. In the case of the U.S. academic research fleet, there are some Appendix D documents and specific fields that we're interested in, and so I've tried to export those to make it handy to do the same kind of thing. So we can get a list of the different hardware devices. So we could just copy and paste this into the Appendix D doc and have our data there. We've got the asset IDs. Again, those are really unique identifiers. Your host name, what type of equipment, and so on. In my case, I'm detecting networks here. In your case, that will probably be different. So we might have to do something custom, different for different vessels. Okay. Let's not save that. The other thing would be the software, and I will go ahead and take a look at it as well for Appendix D. So this was a little bit complicated, but what I did is I actually had to aggregate all the asset IDs that have this particular application installed into this column. So you'll see a comma separated value because we only have a small number of systems, one per OS in this case. You're not seeing that here. But we'll see the installed version, the name of the application or software package, whether that's an RPM or a apt-get or a Mac package or a Windows software package, and then the date of the install. And so we can easily copy and paste this as well into the Appendix D doc. Okay, so in conclusion, that's the state of the current affairs. Some of the things to be added down the road. I would like to be able to do manual asset edits, so being able to come in and edit these entries or export their unique independent data. Or be able to add a device that the client can't run on, some other hardware device maybe that they have to enter manually. So that would be a feature to add. I'll also mention under the data, if you come here, you can get the data, raw data in JSON format which can be very helpful for programmatic purposes. So you might have your application query this API URL and grab the JSON data, so it can get that for all those hosts. And you can eventually do the same thing for the software inventory, which I have a feeling, oh, it does have them. They're listed there, so you can get the softwares and the versions and the metadata all from that API call. Okay, so I think that is about it for today. And it looks like it's taken a while to run that call. But I would just say, if you have any questions, you can contact me at my alaska.edu address, and check the website for the Git repository for any updates. And you can also upgrade it by simply going into the ITAM directory, running git pull origin master, and running the update, and then just restarting the server, and you're done. Okay, that concludes this presentation. Let me know if you have any questions.